Okay, so here we're going to look at a theoretical yield question. It's a little bit more tricky, and you'll see why. So same sort of rules, same thing we do as before, but there's just some little other things to look out for here. So there's a question, we've got 10 grams of sodium metal with reactive excess zinc sulfate. The fact that the zinc is excess tells you that you're not going to work out the zinc sulfate solution is excess. Means that you're not going to work out how many moles of it is. There's just enough to react completely all of the sodium metal. So the sodium metal is the limiting reagent. So this here, 12 grams of metals collected. That's your actual yield in grams. Okay, so at some point we might convert that into moles to work out what our actual yield is in moles. So somebody's done this experiment, they've made 12 grams of zinc. So the first thing you've got to do is have a balanced equation. So we've got sodium metal. It's a metal, it must be solid. And that's reacting with zinc sulfate. So Zn is 2 plus, sulfate SO4 2 minus. So one of each. So it's a solution, so that's aqueous. Sodium, as you know, is a reactive metal. So we're going to end up with a displacement reaction. Because sodium's in group 1, it's Na+, plus, so you're going to need 2 of them for every SO4 2 minus. That is aqueous now, and the zinc metal is solid. So this isn't balanced yet. We've got 2 sodiums here, so we need 2 in front of there. Okay, so now that we've done that, let's have a think about what we're looking at. We want to find out theoretically how much of this could be made. We know we started off with 10 grams of that. So we'll know what is the theoretical yield of zinc if we started off with 10 grams of sodium. So first thing to do then is work out how many moles of sodium are there. So if we've got 10 grams, the molar mass of sodium is 23. The atomic mass of sodium, I say, is 23. So 10 divided by 23 to 3 significant figures gives you 0.435. During a question in chemistry, it is good practice to convert every now and again out of the fraction, because you're unlikely to get error code forward for that, but you would for that. Okay, even though it has been rounded. So 10 divided by 23 gives us 0.435 to 3 significant figures. Now, to go back to my equation, the way it was balanced, for every 2 sodiums, only 1 zinc is produced. So for every 2 moles of Na, you get 1 mole of Zn. So that's how many moles of sodium I started off with. Therefore, I'm going to produce theoretically half the amount of zinc. So I've taken the unrounded version, because that's good practice, and I divide it by 2, and so that'll give me 5 over 23, which to 3 significant figures is 0.217 moles. So this is why this one was a little bit different, because it's not a simple one-to-one. There is a ratio within here, and that's why I'm going through it with you. So that is my theoretical yield in moles. So we need to start putting this together now. So it comes down to here. So percentage yield is actual yield over theoretical yield. So the theoretical yield is 0.217 moles. I prefer to do this calculation in moles, because if you do it in mass, the temptation is to do 10 over 12 or 12 over 10 and not have, you can't do that. The molar masses of sodium and zinc are different, so if you do it on moles, you can avoid that obvious pitfall. So the actual yield we've not worked out yet in moles. We know that it was in grams 12 grams. There's 12 grams of zinc, so we've got to divide that by, what is it, 60, get my periodic table. $65.4. Okay, which to three different figures gives me 0.183. So I'm going to do 0.183 divided by 0.217 times by 100. That gives me 84.3%. So just to run through the main things that we did here, this example shows you why it's really important to do a balanced equation to start off with. It's important that you know how to write your formulas. If you thought it was NaSO4, the whole thing's gone down the pan, hasn't it? Look at your ratio before you work out your theoretical yield, and when you're using this equation, I suggest that you do it in moles and you're less likely to make a mistake. Because so many times I've seen people, you can do it in mass as well. You could have the actual yield of 12 here and worked out theoretically how much moles of zinc reduced, which you, in that case, you would have taken that number and times it by 65.4. But if you do it in moles, it kind of forces you to go through the process. Okay.